All right, go ahead and let's do a little warm up here. Why don't you're going to pause the video and then answer the questions over on the side. Go. All right, so the first one is 5 to the what is equal to 625. Okay, this one is 10 to the what is equal to 0.0001. There should be another 0 in there, I think. 1, 2, 3, 4. Let's see. 1, 2, 3, 4, 5. Did I put one too many in there? No, that's right. Okay. This one is 32 to the what is equal to 2. This one is 36 to the what is equal to 6. And then this one is 8 to the what is equal to 4. Okay, so this one is going to be, let's see, we'll start up here. So 6, this is going to be 4. Okay. This one is -5. Okay. This is -1, -2, -3, -4, 10 to the -5th. Remember, if you have no base here, that means 10. 32 to the what is equal to 2. So that means I'm going to have to do, let's see, 1/5. I think that's 1/5. Let's see. Yep, because 2 times 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2, I did 5 of those. Okay. 36 to what is 6? That's going to be the 1/2. And let's see the oh wait, sorry. I did this wrong. This is supposed to be 1/6. So it's going to be the -1/2. Okay, then 8 to get to 4. Let's see, the cube root of 8 is 2. Squared is 2. So 2/3. All right, let's move on. We're going to talk about the understanding the inverse relationship between exponents and logarithms, F.BF.5. You can pause and read that. So let's go ahead and get to this. All right, this is something you're going to need to pause the video and go ahead and write these down. These are the different properties of logarithms. Okay, now we'll discuss on Monday. I'm going to show you a little bit about some of the proofs, and we're going to walk through some of these proofs. So don't worry too much about wondering why they work, and let's just going to use them as they work, and then together we'll sort of go through why these work. Okay. All right, so let's go ahead and, oh, you probably can't see that very well. Let me see if I can move this thing. There we go. All right, so we're going to use log base 4.3 is equal to 0.792, log base 4.7 is equal to 1.404, and we're going to use those to evaluate the logarithm here, okay? So what I'm going to use is I'm going to use some of those properties here. So we said that log 4 base 3.7 is going to be the same as log 3, right? Let's see, log base 4.3 minus log base 4.7, okay? So then what we can do here is we can say then it's 0.792, and we're going to subtract 1.404, and we're going to end up with -0.612. Okay. Practice again. All right, we got log base 421. Go ahead and why don't we try doing that one? So this is going to be, we're going to say, okay, that we know that 21 is the same as 7 times 3. Okay, and so then we know that log base 4.7 plus log base 4.3. We do those together, which means I can take 1.404, and I can add 0.792, and together I will get 2.196. Okay, so that's how we're going to sort of rewrite them, use them to sort of, it's just more practicing sort of getting in the habit of writing this, the terminology, the notation. So concern yourself more about that and not wondering like, wait, what's going on here? Okay, it's one of these things we're going to get used to the notation a little bit, and then we'll talk about sort of why they work. Okay, going back and forth, rewriting these things a couple different ways. All right, so now we got log base 449. Okay, well, 49, let's try to use one of these things, right? So log 3, log 7, we can say this is log base 4 of 7 squared, okay? And if I use the power property, what I can do is I can pull this and drop it in the front, so I get 2 log 4 base 7, which is going to be 2 times 1.404, which is going to be equal to 2.808, approximately, right? Not exact. Okay, good, good, good. All right. All right, so I want you to just go ahead and practice. Try doing A, B, C, and D now. Okay, real quick, log 6 5/8 here. So this one is going to be, we do log base 6 5 minus log base 6 8. Okay, and then you can use those numbers and you can use a calculator. Okay, I'm sure you just substitute in. This one is going to be log base 6 5 times 8. So it's going to be log base 6 5 plus log base 6 8, and go ahead and you'd add those together, right? You'd add this one and this one together, right? And you can do that on your own. This one we're going to do log base 6 is equal to 8 squared, right? So I'm going to do, that's 2 times the log base 6 of 8. So you just take this one and multiply by 2. And then finally we've got log base 6 of 5 cubed, which is going to give me 3 log 6 of 5. Okay, and we know log base 5 is 0.898. Multiply that by 3. All right, moving right along. So we're going to rewrite some expressions here. We're going to try to expand this one. All right, so there's a couple different ways just looking at this. So we're not going to actually evaluate anything. We're just going to rewrite this a couple of different ways. So I'm going to first break up this fraction. So I'm going to say this is log base 6 of 5x cubed minus log base 6 of y. Okay. Then what we're going to do is we're going to go ahead and we're going to take that, we're going to do the break apart the 5 and the x. So we're going to do log base 6 5 plus log base 6x cubed minus log base 6y. So that's going to give me log base 6 5 plus 3 log base 6 x minus log base 6 y. Good? Good. All right. Moving right along. So now let's do this. We're going to condense this. So we're going to do this and we're going to put it back together, okay? So I'm going to go ahead and I'm going to rewrite this one. So let's start off and let's take this. Okay, we're going to take, so these are all base 10 logs, as you can see, okay? So when it just says log like that, it just means it's a base 10 log. Okay, so the first thing I'm going to do is I'm going to combine these two, right? So this is really 9, or let's say this is 2 cubed, right? Because the 3 is going to get jumped, it's going to go back up onto there, so we'll do this. We can say log 9 plus log 2 cubed minus log 3. Okay, and then I'm going to add these, so we can say this is log 9 times 2 cubed, right, minus log base 3, and then we can go from here and we can say log 9 times 2 cubed all over 3. Okay, and then we can go ahead and we can simplify that on the inside there, and we could say 9 divided by 3 is 3, and then 3 times 8 there. 2 cubed is 8. Okay, so we can do log of 24. Okay, so it's just sort of being able to go forward and backwards there. Okay, understanding how you can kind of break them down. All right, you go ahead. I want you to try to expand on the left and condense on the right. Check your answers and go. Okay, hopefully in this one you said this was log based on 3 plus log of x to the 4th. So then we get log 3 plus 4 log x. Okay. Over here, this is ln is natural log, so we're just going to put these together. So we're going to do ln 4 plus ln 3 cubed minus ln 12. So we'll do the natural log of 4 times 3 cubed minus the natural log of 12. So then we get the natural log of 3 times 3 cubed divided by 12. Well, 3 divided by 12 is 4, so then we've got 27 over 4. I think that's right. Let's see. 3, 4. Oh, no, it's not. Let's see. That's a 4. 4. 4. Let's see. 4 times 3 is 12, so that's going to cancel that. So 3 squared. So natural log of 9. Okay. There we go. All right. Now, we have this also thing called change of base formula, okay? And this is, again, another one that I'm not going to, in this video, I'm not going to go through like a whole proof or anything why it works. We'll do that in class, okay? But I want you to get familiar with what I'm talking about here. Log C, base C of A, okay, is going to be, I can change this so that if I have a new base, different base, I'm going to end up with A log different base B of A and log different base B, same base there, of C, right? That's how this is going to work here, okay? And again, don't worry about, what's happening right now, but just know that B can't be 1 and C can't be 1 here, okay? Those are the rules, okay? A, B, and C need to be positive. B can't be 1, C can't be 1, and you go on from there, all right? So just the way to rewrite it here. Okay, in particular, what we can do then is if B can be some other number, then oftentimes we can use 10. All right, so then we can do log base 10, just write log. Or we could do log base E, which ends up being natural log, right? This is ln E, then we just don't worry about that. So then we're just going to write it as log of C over A could also be the natural log of A over C. It doesn't matter, you're going to end up with the same thing. All right, so let's try it. Log base 3 times 8. I want you to go ahead. No, I'll do this one with you, okay? So basically what we're going to do here is we're just going to say this would be log, okay, of 8 over the natural or normal log of 3, log base 10. Okay, end of story. All right, and we can go ahead and we'll calculate this out in a second. We could also have written it as natural log of 8 over the natural log of 3. So let's take a look and see how that works out here. So let's go ahead and we'll do logarithm. Where are you? Log of 8. Okay. Oh, maybe let's see. 8 log divided by 3 log equals 1.893. All right. Now let's try another new one. Okay. Let's clear it and we'll do 8 natural log. Wait, no. What is that? Where is natural log? Log, natural log. There it is. Is that it? Well, let's see. 8 natural log. Yep. Divided by 3 natural log is 1.0. Wait, did that work out to be the same? Let's see. Natural log. Let's try that again. Clear. So we'll do 8 log divided by 3 log equals 1.89. All right, and then let's clear those and we'll do 8 natural log divided by 3 natural log equals 1.892. So, okay, there we go. I think I forgot to enter before. Okay, so you can see it sort of works out to be the same. All right. You go ahead. Try to evaluate these logarithms right there. Okay? Okay. This video is getting long, so we can check these answers. I mean, you can ask questions about why those answers came up over on the right side there for you in Edpuzzle. And let's see, we've got one more here. Nope, that'll do it. Make sure you do. There's a Khan Academy or two I'd like you to try practicing over the weekend also, and we will check back in on next time we meet.